Hi everyone, welcome back. So, gave you a little tiny bit longer there, but I wanted to pull people back to present on what you've done. I know some people had sort of a few last minute issues, but don't worry too much about that. I think there's been some brilliant work that I've seen some floating around the room. So, really excited to see what you present on all this. So. I've by default I've set this to record. Obviously, if there is anything that you don't want to, and it will go up on our kind of YouTube, which is publicly out there. If there's anything you don't want recorded, just say before your presentation, and I will happily pause this. But this is mainly just to be watched by our community. The other thing I was going to flag up, in the class Tannoy, if you haven't seen it already, on Slack, if you can reply to the thread that I've put in a message there. Click on reply to thread. If somebody from each group could just put in your project title, tag in the people that are in your group using the @ symbol, and post a link to your GitHub as a minimum. And then if you've got any other links, like you've deployed a Streamlit app. I think that's pretty ambitious for the day, but links to slides, any other links you want to put in there, then put that in there as well. It'll just help us when we go back to look at it for points, and also to make sure that we're rewarding points across the groups that are represented as well. So. I think we had. Let me just. Yeah, that's good. I'll keep this up so that I can see that. So I'm going to go through in no particular order. Literally just the order that is appearing on my breakout room screen here. So I'm going to ask each group to just talk us through what you're trying to do, and show us what you've done. If you've got slides, great. It doesn't matter if you haven't. But it would just be nice to see what you've been up to today. So we'll start off with the Project Toy Mech group. If somebody wants to share the screen, talk about what you've been up to. I haven't set a particular time limit on this. There's only a few groups, so I think we should be well within the time anyway.
Should probably talk because it's my the project I suggested, but I'm happy for either of the two to do so. It was fun. We had a lot of.
That's great, Don. Do you want me to screen share at the same time so that I can do the pictures?
Sure, if you want to. I have put it up on a version up on Streamlit now. So
theoretically. Oh, wow. Okay, cool.
Okay, go for it then.
But it should be in the class link. It might not be the same version that you've just done with
let me share while you're talking, so at least we've got something going on.
Yeah.
Find it.
But you should be able to go to the Streamlit app, and that should be there if anyone wants to play with it. So we were trying to do something for looking at making every contact count, which is the idea that if you do a brief intervention to a person, you can maybe help them quit smoking, decrease alcohol use, and maybe do things with weight and exercise. We didn't all get all of those things put in, but we started on smoking, which is the most documented in the literature and kind of almost one of the easiest to do because it's like more binary. So we've created a Streamlit app with a agent-based simulation in it, so you can set the number of people, the chance you are of smoking to start with, and the base chance of them quitting smoking by themselves, and then the chance that you visit in this case, a primary care clinician, but it could be anything. But I think the idea is to make it more generic in the end. And then from that, you can then look at what it's like. So this is running the simulation without any additional mech training. So any additional training, because that's the idea of the mech, is that you give you additional training to clinicians to enable them to give these brief interventions between like 5 and 15 minutes. And so you can see the difference that may or may not make. The setup of this might not necessarily show that there's a great effect yet, because we didn't concentrate on changing the variables to sensible numbers, though we have done some research on those, which is available on the GitHub README. But it does show you the difference between them, and then something that isn't integrated fully into this is that it should output a quarter report, which shows you what numbers you put in. And actually, do you want to go to the down so you can get to see your final intervention? So you have to run that to the end.
Yeah, keep it running then.
Yeah. A quarter report that then, yeah, that's not, it isn't implemented yet. But we've had a lot of fun learning how to use Git with lots of people in a short space of time, like multiple people, and using branches, which I think was really valuable. Possibly quite different to how you use it on not a hack day situation. But you can see how that's diverging quite quickly. And then still going. So yeah, there's some other, again, more variables I might want to put in, which like the effectiveness of mech. So because that's one of the other things is how effective, how much does it change your base quit attempt probability as well? And how well does your training take? So after running for a certain amount of time, this is like, is that worthwhile? Depending on how much your mech training costs, maybe it's worthwhile to have 6 additional quitting smokers. But we can see very easily how you kind of extend this into a possibly a wider project. You're wiggling around, Luke. I'm not sure whether you're trying to show something or you're trying to get Streamlit. No.
Oh,
Sorry, Streamlit, the quarter output.
yeah, so I'll beg your pardon, I'm still on that. Yeah, so this is the quarter output from the same parameters. It's not running right this second, but it was about 2 seconds ago. Typical, isn't it?
Yep, I say that was the last, which is a great idea, and was what Sam suggested, and I hadn't even thought of that as a possibility, and would be really great if that, like if that gets working. Any questions? Anything else you want to see?
That's brilliant. No, it looks really good. I mean, I'm really impressed with that. I mean, so much you've managed to do within the day. I mean, getting an agent-based simulation working in a really useful use of a good agent-based simulation as well, deployed in a Streamlit app. Which also I loved the idea of then downloading that as a quarter report. I think that's really good. It's really nice that you've got. I think this is a really nice example of how you can use the Streamlit visualization. I would argue for a better a visual output and more flexible visual output than the kind of stuff that comes built into Mesa's server visualization, which as I've looked at it before, it uses something that's a bit similar to Streamlit, but a little bit different. But it uses its own kind of tweaked engine, and it does the job. And it's quite effective. It is fairly functional as well. So this is a really nice demonstration of that. So I think that's really good. Excellent work. All three of you done amazing work within that short space of time. So really exciting and lovely to see an agent-based simulation as well. Anybody have any sort of questions? Anything they want to add for any of that? No. Seeing anything, obviously if you do think of anything, do pop that in the chat. But thank you, Dom and team. That was a really good start, a really nice demonstration. What an impressive start to our hackathon there. Amazing what you've come up with in a day. Goodness knows what you've come up with in 9 months. So absolutely brilliant. Well done. Okay, so next we'll have the Datix Data Dive team, please.
I can share my screen. I don't know if Joel's around to give it a bit of context.
Okay. There is.
Yes, I can give it a bit of context. Unfortunately, I haven't been able to be hugely integral to the coding, but it's basically a data set that looks at data incident over the past 5 years. And so we kind of started the day just by checking in and thinking about what we wanted to do. And there was a level of practice some coding, get to grips with some natural language processing, potentially NER, get some nice visualizations. And we decided on a Streamlit app as a approach. We kind of went through a little bit of kind of very quickly about the process maps and stuff around kind of Datex, and then set up a Streamlit app that the others have been able to really progress this afternoon while I've been pulled away. So Beth can show what they've produced.
I'd say variable levels of success in terms of what we've tried to do. So wanted to show the data frame, and we've got we can select by division and specialty. Is this actually going to have anything in there? So this is our data frame. We have been looking at different ways of selecting here, because sometimes you might want to include everything to start off with. So there's a slightly different approach in the data summary where there's a select all option. It just looks slightly mad, unfortunately. But let me choose some options. So this is where we can show with a plotly plot instant rates or instant counts by hour, by day, with an interactive heat map, which is showing when the incidents are occurring over the course of the day and over the course of the week to try and find hotspots, and then a static heat map there. And then there's been a couple of different approaches to looking at some of the fields around the incident. So drop that in there. It's doing something. So again, there's the option to choose the specialties, and it's just generating some word clouds. Probably shouldn't have used the completely massive file. That might have been a mistake. Here we go. So it's possible to look at the what happened field and thinking about the action that's been taken, which unfortunately doesn't seem to be working. I'm not sure why that's not running.
Oh, right. The output folder is missing from the actual file. Need to add that one in. That's fine.
Okay, no worries. Thank you. And then we've also got alternative word clouds, but where there's the option to remove words from there as well. So we could rerun that, pulling out or removing, in this example, reporting. So that's still there. I'm not quite sure why that's still in there. That was the plan anyway. So just looking at different ways of visualizing quite a complex data frame for stakeholders. Don't know if anyone else in the team wants to add anything that I failed to highlight.
Well, this is also gone.
Oh, sorry, I was going to say we also had quite a lot of fun trying to work out how to use GitHub for such like so many users, doing so many changes
Yes.
in such a short space of time. Both one not being that familiar with GitHub in the first place, and then trying to use it for something which is probably not the same way we'd be using it normally.
Yeah, absolutely.
It's quite fun trying to work it out, trying to do all our pushes and pulls and syncing our branches, forks and stuff, and our branches.
Yeah, good.
To me, to you.
Yeah.
Yeah, lots of good practice. I think. Yeah, it was quite deliberate why I got encouraged everyone to use that. I mean, this looks really good. I mean, it's absolutely great. And what I really like about this is such a nice way of you've really given a lot of thought into creating a really interesting and useful interface for being able to explore data. You know, I could see this kind of thing being deployed. Really nice use of different way. I liked the fact you thought about different ways in which people might want to kind of filter that data, different ways to visualize it. Really nice ideas with the word clouds. So I thought that was really great. Your issue with the removing stop words you have my sympathies. I ran into a similar issue with the app that I developed, the PIMS app, and I can't remember how I got it working. There was something that I had to do to get that working. So it's probably something simple, but again, a really nice idea to do that. So really nice development of an interface there. A lot of really nice thought into the kind of design aspect of that as well. And again, fantastic to see a Streamlit app used so well. So really nice demonstration that. So yeah, thank you very much. Any questions or anything anybody else wants to add on any of that? Great, fantastic. Well, what fantastic hackathon presentations these are. Brilliant. Okay, so next up we've got the patient transport discrete event simulation. And I did sit in with this group for quite a bit today, and I think probably they're going to say one of the key aspects of learning is sometimes these things can get a bit more complicated than you gave them credit for.
Absolutely. Okay, let's try and share some slides. So, as you say, it's it did get a little bit more complicated than we thought it would. Can you see that okay?
No.
Not yet. Okay, I'll try again. Let's try that.
Oh, something's coming through now.
Is that working?
There you go. Yeah, that's working.
Okay, fantastic. Sorry about that. So it was my mad idea. So sorry to everybody for that one. But no, joined by a really great group that really got involved in it, which is fantastic. I'm trying to solve a real problem. So this is one of our patient transport vehicles. So it's basically moving people to hospitals for appointments, often several at a time. So we need to get people on time and returned home from their hospital appointments. And this is a genuine real world problem at the moment because we're facing increased demand without increased funding to meet that demand, but we still have performance targets to meet. So what I wanted was a tool to explore the what ifs with our managers. So, what if we had more vehicles? What if we had less vehicles? If we drop patients earlier or pick them up later? Is it okay to be 2 minutes late? That kind of thing. Lots of considerations. So patients have different mobility needs. For instance, wheelchair users, people that need a stretcher for their journey. And that determines which kind of resource, what kind of vehicle they need. Different appointment times, things like that, and vehicles will have their capacities that they can't exceed. So we had a really good group discussion to start off with around what kind of problem we felt it was, whether there was things like a geographical routing element to it, which I think we think there is, but we probably didn't have time to compress it into this. And we'll be veering dangerously close to this being a really complicated optimization problem. So we settled on a discrete event simulation, which this is our very simple sketch out, map out of it. So at the top is a kind of a timeline of how the journeys work. So the
Sorry, James, we can't see that. We've only got the slide outline.
Okay. Which bit can you see? Oh, right. Can you see the one that says the problem and the aim, considerations, etc.? No.
There we go. It just appeared just before you stopped sharing.
I'll try the sharing again. What if I do that?
There you go. That's better.
You see that one? Okay. I won't put it in slideshow mode just in case it's the slideshow.
Yeah.
You see that one with the methodology?
Yes. Yeah.
And the diagram. Great. Okay. So yeah, basically the vehicles leave base. There's a wait while they move towards the first patient, and then they wait again while they load the patient on and move towards the second patient, and then they wait again as they move towards the hospital, etc., etc. So that was our little process map there of patients arriving in our model, being assigned to resources, getting to hospital, and then exiting the process. So yeah, and then we just basically ran into a lot of real world complexity. So it was really different we felt it was really different to what we learned in the lectures, taking that and applying it to a real world problem, For example, where we'd learned about random arrivals and elapsed times. In our case here, we've got appointments throughout the day, so we had to build an appointment book and things like that. We basically had to make a lot of simplifications and kind of relax the problem to try and make it tractable for us, really. But that led to some really interesting approaches, like an appointment book rather than sampling from a distribution, using a time as a proxy for the different mobilities. So basically like sampling from a distribution of times. So some patients will take longer than others, which might be a kind of proxy for a stretcher versus a walker, for instance. We looked at things like containers for capacity, but we didn't actually go with that one. So we dropped down to doing 1 passenger per vehicle. We had multiple patients at the same collection times. I mean, really, it just got tricky really quickly, but it was really great learning. It was lots of fun, and I think we've got a really promising start. We've got code that looks like it should work. We just had a couple of little bugs to iron out, so unfortunately we can't sort of show you any real world. Although Sarah did have one that had run a couple of times around, so maybe we could flash that up quickly. But it's been a lot of fun, a lot of good learning. So huge thanks to all that got involved and participated. Thank you.
Fantastic, thanks, James. Yeah, Sarah. I mean, if you've got that, if you're able to share that, would be great. What I really loved about this project, I think this was a real kind of demonstration of the importance of conceptual modelling, which is what you're all going to be doing as kind of your first steps on your projects. Is actually trying to take that real world messy problem and translating that into a designer blueprint for a model. And that is not always straightforward. You know, we've given you, in the lectures, we're teaching you Simpai, we're giving you and here's your nice little ED where they come in, they get triaged, and then they, sort of see a doctor, and then they go over here, or here's your GP surgery, and they see the nurse. But, the real world is full of complexities, and you will find, probably in the vast majority of stuff that you do, that you'll quickly run into things and think, well, hang on, the basic framework will be the same, but I can't just adapt that ED model we did because actually, my model needs this. So how do I go about doing this? Now, one of the beautiful things about using a free and open source approach like Simpai means that you are in code, so you've kind of got that flexibility. You're not battling against a simulation package that you are trying to have to work out how to kind of fudge this thing that it was never sort of set up to do within this. You've got flexibility, you can code your way out of anything. And I think you were gradually discovering that over the course of the day. And I think what was really nice, I mean, certainly from when I was in the room 15 minutes before we finished, I think your main bulk of your code was actually working. I think it was just the little bits of to get it sort of displaying the results and stuff like that. But I think you were pretty much there. So I think you'll find you're not far off with it. And hopefully that's given you lots to think about in terms of how you might translate real world messy problem into how you might think about it in terms of a queuing problem or whatever you are trying to design. So yeah, really nice approach, really nice teamwork in this team as well. So yeah, really well done. Anybody had anything to add or any questions on that one? No, great. Okay, thank you very much. This is a fantastic start. I mean, genuinely, you started about 9:45 this morning. So it's pretty impressive you managed to come up with this stuff so quickly. You'll have 9 months for your projects or nearly. So hopefully this is encouraging for you. So then I think we didn't have that project run. So I think it's the kidney stone one we've got next.
Oh, hello. Sorry, I'm just doing some pre-flight checks.
Okay.
Just imagine there's a huge drum roll playing.
There's a lot of hype for this now.
Yeah, I know. Well, we managed to get it working. So,
Oh,
right,
great! Fantastic.
standard things. Can you see my screen?
Yes.
Right, I've gone the unconventional way and started at the end of the PowerPoint presentation, but I'll do it from the start. So this is called a calculator, which is a pun because a kidney stone is also known as a calculi. So you can then we've tried to create a calculator in order to see if we can predict the chance of success of a treatment for a kidney stone. So these handsome young men are all probably American and well paid. And this is a lithotripsy machine. So there are many ways to treat a kidney stone, and one of them is via something called shockwave lithotripsy, which fires sound waves at a stone with the aim of breaking that stone up so it passes without you having to have an operation. So it's a very good method of treatment. And it was actually found by Dornier because his planes were vibrating in a very unusual way, apparently. And then he figured out how to use those vibrations and how to arc them and focus them on a particular point. And for some reason, he decided kidney stones. So it's been known that there are patient and stone factors which impact on the success of lithotripsy. So the density of a stone, the size of a stone, where the stone is within the urinary tract, and potentially maybe some factors related to age, sex, as well as if this is an emergency or an elective procedure. So can we predict treatment success? So we've got some cool data. So we'll have 1,000 patients who've been treated with lithotripsy, and the outcome is yes or no, so binary outcome, and then patients can be treated if they don't have success in the first go, another go, up to a maximum of 4 goes. So for our data set, we looked at patients who have had success in 4 rounds of lithotripsy. So I'm going to stop that, and I'm going to share with you the app that we made. Different share. So here you can see, so this is the Streamlit app, this is the calculator, and this is a nice little bit of information about there. So then we've just had a quick loop through the raw data, and we've come up with some pretty graphs just to see if there's any difference in the baseline characteristics between patients who had success or not. So success of treatment, non-success of treatment, and there's no real difference between the sex of the patient or the side, which is, to be honest, what I'd expect. And here is the success of treatment depending on the location of the stone. They're numbered, but I know what they mean. This is interesting because this is in real world experience, and also what the data suggests. Stones in this particular location, the lower pole of the kidney or the upper part of the water pipe, are notoriously difficult to treat. And it's interesting that that's been pulled apart in our data. And we've got some other bits and pieces on here as well. So we then created a cat boost model, and they're feeding in our various patient and procedural factors. And then we plug this into a Streamlit app on here. And then if you run the model, so it pulls out all the information, it feeds it into the model, and it spits out whether or not the success or not of the treatment. We then went one step further, and I hope this works. Oh no, hang on. This will be worth it. 1 second.
Yeah, no worries.
So you can enter text which you might receive in a standard CT scan report. So CT scan report is what's used to diagnose kidney stones. This is what a report would look like. So we fed this in to a natural language processing module, which has picked out the relevant information, I hope, with a typo. So 8mm stone, and if you change that, hopefully it works. Oh no. Oh well, it did earlier. It should. Yeah, there we go. That changed. So it should pick out the relevant features from the text and then feed it into the model. What is interesting, Dan, is that I think despite changing all of these, I just think the model is quite happy to say that all treatment is successful. So Mike was suggesting that we alter the threshold, because at the moment it's at 0.5. So maybe that's something we can play around with in the future.
Yeah, no, that sounds yeah, that's if it's the model that's doing that, it sounds like it's a threshold issue. And in fact, if you look at the area under the receiver operated curve, that should give you an indication of whether a different threshold would help you.
We didn't get there, but that's a really good idea.
Yeah, no, well, I mean, I don't know if we're not getting there, so yeah. Yeah.
Thank you very much.
Yeah, no, fantastic. I mean, this is absolutely amazing. Again, I'm sort of blown away by how much you've managed to do in a day to get a full-on Streamlit app that that is very, very usable as well, and that incorporates a classification model and a natural language processing a facility in that as well that can read out that information. I mean, that's amazing. That's really, really good. I mean, this is a couple steps away from an app you could just put out there and we can shout about and use. So this is really, really strong stuff. And again, I'm constantly amazed by how much you've all managed to do. I genuinely want to laugh at it's kind of hilarious how much you all managed to do in a day. It really is amazing. But yeah, thank you so much. What an amazing little product this is. Fantastic, thank you. So we've got one more group to go, I believe. Please share if I've missed anyone. But Jin, I think, I don't know if it's just you left, but we've got the building classifier for tagging research data project that you were working on.
Sorry.
Oh, that's okay.
Thanks, Dan. Just share my screen. Right. So this was a long-standing problem, and it's still not. It's far from complete. But this today really helped, and Felix, who had to leave slightly sooner, he helped immensely in asking the right questions in trying to break this problem down into smaller quick wins that you could win iteratively, and we managed to build a very, very basic machine learning model, but it's better than nothing. So the idea is the motivation behind this is it's a long-standing problem within the part of the NIHR that I work with, which is we have the NIHR holds study information, study records that are referred to as research records here on the central portfolio management system and the open data platform, the latter of which I closely work on. And here each of these study records are manually tagged with ICD-10 based chapters and blocks. And these are crucial in the way that we report on existing studies, on research that is going on that the NIHR is supporting in delivery. And the problem is right now, even the less than 50% is an exaggeration. It's a fraction of the entire portfolio. It's only a fraction of the study records that have been manually tagged. So there's a pressing need to be able to somehow help the persons responsible for tagging these studies. We have clinical coders and specialty experts who deal with this problem. Like this was something that was achieved today, which was a very baseline model. So we pick up one study record. We apply pre-processing. I will go through individual steps. We combine the study record with the ICD chapters in a one hot and coded document. Then we try to convert the textual data. So each study has a research summary. It has a study title. It has a study short description. And inclusion and exclusion criteria, which gives you a good amount of information about the study. The only caveat is this is textual string information that we need to first convert into appropriate vectors for the machine to understand. My intention here was to work with Medcat that Dan and Sami have told me about previously. But again, the intention was to get a minimum viable product. And ultimately, obviously, create a multi-label classification, multi-label, multi-class classification model with sklearn. Sklearn, again, the device that we used here. So what is multi-label, multi-class classification? We have looked at that before, which is essentially imagine we have one study record. I do have this information, so not sure if you can see my entire screen, but
yeah.
These are two study records, and these are randomly selected labels. I think class A, class B is a misnomer. These are really labels, which in my scenario are ICD chapters. So one study record can be tagged to multiple ICD chapters, and we have a total of 22 ICD chapters as per ICD-10 coding. Which makes it a multi-class, multi-label classification problem. The way sklearn handles that problem is it divides, it essentially treats each label taken with the input data as a binary classification problem. And I did not have the time to look at how it is aggregating that final prediction value, but I think I need to do some more study there. But if we break down the problem further, we try to look at textual features on the left and study metadata on the right, and we further whilst we were in development today, which was again short period, short number of people, we decided to, at the last minute, we decided to ignore the metadata in the very basic classifier. And and the evaluation is terrible. I've only managed to look at accuracy right now. Haven't looked at in any of the other metrics, specificity, precision, recall. But it is quite deplorable. I really need to work on this further. The next steps, quite a lot of them are evident. Add metadata features to retrain the model. Train model only on the records that have ICD-10 tagging. So I made a blunder, which I realized towards the end of this process, that I had included. A large part of this problem was the data engineering aspect on SQL, so which I'm not talking about because it's not entirely relevant. But I think Dan, in fact, or others on the call, I need to understand this. So there are some 20,000 odd records that have ICD-10 tagging, and we have a total of around 50,000 records on the entire central management portfolio system. So 20,000 have some ICD tag associated with them. When training any model, do I train strictly on the 20,000?
Yes, you don't. As opposed to what? Sorry, as opposed to training on ones that don't have it. Is that what you mean?
Also training on the so say yes, as a combination of those that have and don't have it.
Oh, I see. Right. Yeah. You're because what you're essentially doing in training any classifier model is showing it examples of what the correct answer should look like. So you need to ensure that the training set represents how you want it to classify and the sufficient information that it can try and extract the kind of hidden patterns within it to sort of make its own sort of rules about how to then future predict things. So yeah, you want to you'll need to carve up that 20,000 in terms of a training set, probably a validation set as well, really, and a test set before you go and then apply it to the ones that just haven't got the full coding on them. Yeah.
I see. I think I follow that. Done. The only reason I asked that is so for the delta that are not tagged right now, I'm not trying to make the model think or learn that these are the kind of records that will have, say, a 0 against an ICD against an output Y variable, because they've just not undergone that process. So we don't know what in an ideal sense, all the 50,000 or 60,000 records should be tagged to some ICD code. So in that scenario, we would be better off not training the model on any of the ones that are not tagged, right?
Yeah, because you need your data set to be labeled, and essentially the ones that aren't labeled, so you can neither train nor validate nor test on them really, because you don't know the answer. The ones that are missing, that's where you take your trained model that you are happy with its performance, and you're ready to deploy it, would then be used to say, okay, I will now use the model for these ones. But yeah, you need your labeled data set for the kind of training, validation, test aspect of it.
Okay, thanks. Sorry for that very funny.
No, it's a good question.
Yeah, I think that's about it. There's no front end. That we barely got this off the ground, but
it's still very impressive. The amount you've managed to kind of explore one day. This is a big thing, and I think managing to develop up a machine learning model like that. Don't be dissuaded by poor initial performance either. Sometimes it's just you need a different model. Sometimes you just need to. So there's all sorts of things you would look at in terms of look at the ROC curves and see, okay, is it just that the threshold's wrong, and that gives you some idea of the potential of it. Is it the model's wrong? Is there stuff that's missing for the data? We've got too much data in there. All this kind of stuff. In any machine learning project, you're gonna spend a lot of time just fiddling around until you kind of get a model that seems to perform well and that you're happy with, or in some cases you find you can't. I mean, we've had lots of HSMA projects before that have concluded, no, we can't train the model to do this, at least with the data we've got anyway. And that's kind of a valid output of any machine learning as well. Sometimes the answer is no, but this is why these things are always a bit more exploratory. But yeah, really nice demonstration. And as with all of these projects today, I think really excited to see how these things could actually be further developed and used and implemented, because I think there's a lot of fantastic potential on all of those. So.
Dan, may I ask a question on that one?
Yeah, sure.
Because I played with something similar, looking at coding some clinical outputs, and So if you take the clinical data, anonymize it, and send it to ChatGPT or Claude or wherever, you can actually get some very good results. Now, I tried to reproduce that on my own machine. I mean, I've got a brand new Macintosh with as many cores as you like and all that sort of stuff. And basically, for a paragraph to get anything like the performance I'm getting on the online things, I have to leave my machine running for a couple of days. And that's just implementing the model. That's not training it. That's just implementing it. And so I wonder if actually it wouldn't be better for us to use a local our local machine learning or our local computing power to make sure this thing's anonymized and presented and pre-processed appropriately, and then actually send it off to some data farm to do the actual text mining. Because I just think the amount of processing power is just extraordinary, and I think we underestimate it until we try and do it ourselves.
Yeah, it's a really good point, because so a lot of these large language models that are at the heart of things like ChatGPT and or GPT that is underneath ChatGPT, and all of these models like BERT, etc. These, I think we touched on it a little bit in the natural language processing section, but these things are you do not want to be training them on any hardware that a normal human being will own. These things are trained on supercomputers, and it takes a long time on those. The most you can hope to do, and this is why when you tend to use these things, these transformer-based models, you tend to grab one off the shelf, and at the most you might do a bit of what they call fine-tuning, which is basically where you take the model that's pre-trained, but you add in a little bit of your own training too, and that's known as fine-tuning. Even that, you're going to need a hefty GPU as a minimum, and you're still going to be running it for a prolonged period of time, but it is doable. But this is why when we showed you Spacey, we're using pre-trained models, because Spacey models are a little bit different, but they're the same kind of principle. They use these kind of large language model infrastructures, and this is why you do it. And in fact, the same principle you can add to a Spacey trained model, but it is more tricky. So yeah, I think you're absolutely right. I think there's a lot to be said about I think some natural language processing tasks you can achieve very well off the shelf. Just implement that model and get fast predictions out, depending on what you want to do. But where the large language transformer based models are so good at some of this stuff that if you've got anything like that, then actually I think it's more, as you say, it's more about having a sort of understanding about how these things work, so that you can kind of prep them and better understand how you feed in the outputs and get the feed in the inputs and get the outputs, because it is certainly not practical for most people to be training these large language models. So yeah, it's a really good point, I think. Cool, thank you very much, and thank you, Jin, and thank you to everyone for presenting today. That was some absolutely amazing presentations. Oh, Dom, sorry, you got your hand up there.
No, I just raised it now, so it's fine. I was going to ask, is that can at least my project be converted into a second HSMA project?
Oh yes, please do. Yes. Yeah, no, absolutely. Any of these, if you want to pursue them, and if these are things that you want to work on, and I think all of them have scope for that, absolutely register them as an HSMA project, because this is stuff that we want to see. This is all impact from the program, and all of these I could see being used, and you've made such a head start on at least the very thinking, but in some cases the development of this stuff. So yeah, please. I mean, I think Heath's got the current record for. I can't remember, Heath, if you've registered your third simultaneous project yet, but you can have as many projects as you like. We don't care. So yeah, please do.
Yeah, I've sent this one, the little app, to the stakeholder already to have a look at. So
fantastic. Yeah.
I think I'll have 3 this week, Dan.
Excellent. Who knows how many you'll have within a month's time, but yeah, no, fantastic. Yeah, so please do that. Because I think all of the projects we've seen today have so much potential, and like I've said about all of them, that you could imagine these things being used and useful, and ultimately this is the whole reason we do HSMA, is for you to create stuff that uses these fun methods, your new skills, to create stuff that is useful for your organizations, and that's the thing that we need. We need impact. Yeah, absolutely. Please do register those, and you've already got half the work done if you want to do that, because you've already written the descriptions. You've got a working prototype, or very near to it in most cases. So yeah, please do that. Fantastic. Thank you very much. Well, thank you everyone. I hope you enjoyed today. Thank you for coming along. As I say, it was just a bit of a sort of new optional session we thought we'd put on. Hopefully it's been useful for you, sort of helping to transition to the project phase. Certainly I think there's been lots of really interesting learning that I've seen today, which is exactly what I wanted to see. Lots of people talking about using Git in earnest. That's really good. This is a good thing to get used to. But also, just as I said, some of these aspects of trying to think about how you take not a nice Dan prepared example or a Sammy prepared example that we've given you, and sort of creating the code for that, but actually what things look like when you start looking at the messy real world. And this will happen to you all in your projects, and you'll get the data back and you'll find that the data isn't as good as you thought it was, or it doesn't contain what you think it does, and you'll spend your time making lots of decisions and adjustments, and fudges, but you will get things sort of working in the end. So this is a really good experience, I think, for you all to sort of have a mini taster of some of these potential real world issues. So just a reminder, we're now in the project phase of the program, so you can all sort of crack on with your projects. Do keep posting on your project channels regular updates. It just helps us to be able to see what you've been up to. So it doesn't have to be anything lengthy, but just so we can see. And do, obviously, if you are stuck with anything, do post on there as well, and shout for help, and we'll see what we can do, and or others might be able to help you as well. And we'll have the first HSMA forum that will be coming up next month on the just looking up very quickly, the 19th. So 19th of November will be the first HSMA forum, where everybody that's working on projects will come together and basically talk about what they've been doing, and have a bit of a sort of show and tell and share ideas, and all that kind of thing. And as we develop some masterclasses, we'll obviously post out information about those as and when as well, and we'll make sure we give you lots of notice before sort of putting out dates for any bookings. Okay, cool. Unless anybody has any questions, we will close off there. Thank you again for coming along today, and I look forward to hopefully seeing you all at the forum very soon. But I can't wait to see how your projects progress after another day of seeing 5 fantastic projects created in 6-7 hours. I think that's amazing. So brilliant work, everyone. Just in terms of points, thank you for, if you haven't already, pop in the class tannoy your links. It looks like everyone has, but if you haven't, please do that. And Sammy and I will have a chat about points to award, and we'll post as soon as we've done that. Brilliant. Thanks, everyone. See you later.
Cheers, Dan.